This video will explore 4 different ceiling plane configurations used to define the bottom chord profiles of our truss envelopes. For our examples, we'll be using a variety of ceiling planes including flat, sloped, and vertical. Vertical planes are required and must be cut improperly to automatically define steps in bottom chord profiles. Let's get started with the first example. Example 1 has a flat section that transitions into a cathedral ceiling. Example 2 has a flat section transitioning to a vaulted section, followed by a vertical step and then another sloped segment taking us back down to the standard height bearing. Examples 3 and 4 are similar in that the bottom chord profile is flat, then steps up to intersect with a sloped segment that returns down to the standard height bearing. Let's dig into each example. In example 1, we need a sloping plane defined in the front wall. The interior plane requires a work line used to define the sloping ceiling plane. Notice that planes placed on a work line allow you to define the elevation. In this case, the elevation is at 8 feet. In example 2, we'll use the same sloping planes as the first example. However, we'll need to add a work line and a vertical ceiling plane. Vertical ceiling planes are defined with a slope of 90. We'll also notice that the vertical plane has an elevation of 9 feet 6 inches to connect the 2 sloping planes. A good way to determine the height of the ceiling plane is to review a truss design to get the dimension. In this case, we will trim the truss envelope back, create and review the design, and then pull a dimension to verify the vertical step. The vertical offset is 1 foot 6 inches, which added to the bearing's top elevation makes it 9 feet 6 inches. If the vertical plane elevation is set at 8 feet, the truss will still profile. What is critical is that you cut the vertical plane to the sloping plane on the front wall. To demonstrate, let's cut this vertical plane. Select the plane. Select Cut or Recut Plane. Shift-click the left work line. Click the front plane to define the upper intersection. Shift-click the right work line. Select Finish Cutting. Let's recalculate the envelope and regenerate this component. Reviewing in 3D, we see the vertical plane is bound by the left and right work lines between the 9 feet 6 inch plane origin and the intersection with the front plane. In examples 3 and 4, vertical planes are also used. They are applied on work lines, but notice the elevation is 8 feet because they are connecting the sloping plane to the standard height flat plane at 8 feet. To wrap things up, we'll generate component designs from the project menu. Toggle our truss visibility to view designs for our different examples. And lastly, we'll toggle off the work lines to view our designs.